Okay, so what I want to do is I just want to do a recap on what we have learnt so far, and then I want to get into, we're just going to work through these labs, and I want to try and get up to the stage of implementing a static label switch path. So first of all, MPLS. Let's just take a look at the basic concepts of it. So first of all, what does MPLS actually stand for? Multi-protocol label switching. Okay, so basically what we are doing is we're basing our forwarding decisions on a label which we insert into the frame. So our forwarding decisions are not made based on the IP address. Okay, so as we send the data through the provider's core network, we're going to be making forwarding decisions based on the label value. So just step back a little bit and just remember where MPLS fits into the scheme of things. So first of all, it is a service provider technology. It's not something you're going to use in an enterprise. Second, the purpose of MPLS is for us to control, or for a service provider to control traffic that is transiting through their autonomous system. Now, it's either transiting through their autonomous system because it's going from a upstream level, maybe an upstream tier 1 provider, or maybe an upstream tier 2 provider, and going to a downstream lower tier provider. So it's either transiting their system because it's going from an upstream provider to a downstream customer, perhaps, or it's transiting their system because the label switch path actually forms part of a customer's VPN. So we'll get into that later on. We'll actually be setting up or using MPLS to set up customer VPNs. So this is where a service provider implements the VPN for the customer. Okay, so we'll get into that later on. Talk about that. So let's just get back to the basic principles of what's happening here. So the first step is that we have our frame. So we've got our layer 2 header, we've got our data, which is of course our packet, our layer 3 packet. So here's our frame, and into our frame we put this MPLS header, which the main part of this header is a label value. So referred to as a shim header. So it's a very small header. The operation of inserting the header is called a push operation. So the function of putting the header into the frame is called a push operation. So the frame then traverses our network, and forwarding decisions are based on the value that is in that label. Okay, so that is the basic concept of MPLS. But now that we are able to make forwarding decisions based on something other than the IP address, that does open up a whole bunch of other possibilities for us. So here's our closer look at our header. We've got a label making up 20 bits of that. We have got a class of service capability there, which means that we're able to prioritize traffic and add time to live. Okay, so the things about labels, things that we're going to learn about labels, or have learned about labels last week, is that they can be assigned manually, and that's what we call a static label switch path. And when you assign labels manually, what you do is you go along to every router in the path and you say to that router, when you get this label value, you're going to forward it out this interface, and you're going to replace it with this other label value. So what happens is the first router puts the label value onto this frame. It then forwards out the frame. The next router that gets the frame has to know what to do with that label value. So a static path requires us to tell every router in the path what the label value it's going to be receiving and then what to do with it. And then finally, when to remove the label, which is called popping. Okay, so the pop operation removes the label. So the thing is that we can do this manually, and we are going to do it manually. The first one we create will be a static label switch path. But normally you don't do it manually. We're just going to do it just to kind of get an understanding of what's actually happening. Normally you don't do it manually. Normally you do it using a thing called a signaling protocol, or otherwise known as a label distribution protocol. And we looked at a couple of those last week. So the labels are going to change at every segment in the path, and the transit router, so a router in the middle of the path, is going to receive a label, do a lookup, and then it's going to swap the incoming label with a new outgoing label, which means that the labels only have local significance for a particular router that's doing the lookup. Some values that we have for labels, 0 is a reserve value, it's called a explicit null. 1 is a router alert, 2 is an IPv6 implicit null, and 3 is an implicit null. We actually use 3 as a special meaning. When a router gets a label value of 3, that tells that router that it should pop the label, so it will not put a new label on. So it will be the last router to receive a label in the path. And we also discovered that normally happens at the second last router in the path, which is called the penultimate router. So this, what's the mechanism? The mechanism for this lookup is contained in a table called mpls.0, and what we have is an incoming value. We have got a lookup there which will reference an interface, and we have got an outgoing value. So in this case, incoming value 10000050. The interface reference there, GE106.0, and then they've got the outgoing value of 10000515. So that is a typical transit router type scenario where the label comes in with one value, gets forwarded out an interface based on the value, and gets a new value on its way out. So it's kind of sort of recapping the things that we have learnt so far. So a bit of terminology here. We have a label switch router, which is could be any router that performs MPLS lookups and forwarding. So really any router in the path, very simply. We're just going to call them routers for our purpose. LSP, a label switch path. It's a unidirectional path, so it only goes one way, which should automatically make you think, okay, well, where's the return traffic coming from? And that means if we do want to have a two-way path, which we will, we need to have a LSP going the other way. Generally within a single MPLS domain, so within a one-at-a-time system. Okay, so we have an ingress router. An ingress router is actually quite significant in the scheme of things, because as we go on and we start to look at these signaled LSPs, we'll find that all of the signaling setup is done on the ingress router. So let's one of the most important routers in the whole path. Packets enter at the ingress router, and it's upstream from the other routers. It does a push operation, and then as it goes through, we get to the transit routers, which are the ones in between really the ingress and the penultimate. In fact, penultimate is also a transit router, so really in between the ingress and the egress. And it'll do a swap operation, or it may do a pop operation, depending on where it is. Penultimate router is the second last router that will do a pop operation, so the label comes off. And of course, it does a lookup before it pops the label, so it knows where to forward the label to, and it will then arrive at the egress router without a label, and then be forwarded based on its IP address after that. Okay, so the basic concepts of MPLS. And some configuration, which we'll get into today. We're going to actually setting up a static path today. So we have to set up our interfaces for the MPLS functionality. So we must add family MPLS to our interfaces. Also got to go under the edit protocols and add the interfaces that we're going to be including in the protocol under that hierarchy. We can use the interface all, and we can exclude certain interfaces, which may be a more efficient way of doing it. Just note that you won't ever need to put your management interface or include your management interface in the protocol. Okay, so to configure a static label switch path, we're going to go under protocols MPLS, give it a name, and then we're going to set this up. So it's important to understand we're going to set this up on the ingress router. So we're naming the path, setting it up on the ingress router. We're going to specify the name of the LSP. We're going to specify the next hop router, and we're going to specify the last router, the egress router, the end of the path, and we're going to tell it what is the label value that we're going to push onto that frame. Here on the transit router, what we're going to be doing there is setting up the incoming values and the outgoing values. We need to tell it where its next hop router is. So we'll do the lookups on the incoming value, do a forwarding lookup based on the next hop, and then do a swap operation. And so we'll finally get to the last router, which will pop it, or the penultimate router, which will pop the label. Now, some label values, static values, we've got 1 million through 1 million, and we've got there 48,575. So there's our label values for static. Now, BGP is, as you know, the BGP is involved in the process. Why is that? Because it's BGP's job to direct the traffic into the LSP. Why BGP? Well, because BGP is the protocol that's handling the routes between our autonomous systems. So because we have got traffic coming in from a different autonomous system, and then transiting through and going out into another autonomous system, it is BGP that is handling the routes coming in and obviously going out the other end. So it's the BGP then is the protocol that has to know that its next hop for that traffic is into the label switch path. And we also discovered that that information is contained in the INF.3 routing table. So here we have example of BGP. We're going to do a lab on this. So this is part of our very first lab, is setting up this BGP arrangement. We will set up an internal BGP peer. We'll set up an external BGP peer. So wrap resolution on BGP, something that we just kind of need to get a head around. And we're going to look at this when we do our lab. Is that we've got a route coming in from site 2. That route is advertised to R5 as an external BGP route, and it's going to be re-advertised by R5 to R1 as an internal BGP route. The main point about this is that the default behavior of internal route advertisements is that the next hop is not updated. Next hop information is not updated when the route is advertised, which causes a problem because R1 then gets that route and it's still got the original next hop, which is over in site 2, and R1 has no connectivity or no reachability information to that next hop. So the solution is to make the BGP change the next hop through using a policy. So this is actually the outcome here, is that we get this unusable next hop because R1 has no clue how to get there. And so you then go and have an export policy, and R5 would change the next hop to itself. And then of course R1 knows how to get to R5 because R5 is included in the network's IGP settings. Okay, so then it knows how to get there. Alright, so we'll do a lab on that. We'll sort that out. And then once we've got that sorted out, we're now ready to go ahead and set up our static LSP. Okay, so that's kind of where we want to get to today. We'll get that lab done. And so we'll go in, we'll set up our protocols, we'll set up a label switch path, we'll set up this these routers. We'll have to set up our ingress router, which is probably back in the previous step, right? We'll set up our ingress router here. That's our configuration on that slide. Then we'll go and set up our transit routers. So in actual fact, in our lab, our transit routers are already set up. They're set up in our core. They're already there. So we're just going to set up our ingress router. And then we'll test that it's working. Okay, so that's really our goal today, is this morning, hopefully it's done. We want to go ahead and set up this label switch path, make sure that our traffic is getting routed through our label switch path. The reason that will be chosen is that the label switch path has got a better metric, so it will become the preferred path. Got a better metric. It also has a better preference value, so it will become the preferred path for that traffic. So it's actually BGP that installs the label switch path as the next hop for us, and we can go and take a look at that in BGP as we do a show route, and we'll actually see the push statement on the BGP route. So a few things here is to learn is that actually BGP is carrying label information. So BGP is intrinsically involved in the MPLS protocol. Okay, so in the process of implementing MPLS, we are going to be configuring, we're going to be doing a lot of BGP configuration, because BGP is carrying our label information and directing traffic into our label switch path. So we're going to be working with BGP a lot in these labs. Okay, so ingress router, a bit of a recap here. Ingress router behavior is we're going to be it'll signal the LSP to the egress router, install the IP prefix to the egress router into the inet.3 routing table. Remember that routing table is used by BGP. Specifies the LSP's ingress interface label assigned by the downstream router. So that is going to result in the MPLS routing being set up, or BGP finding the path in the INET.3 table. Finding the label switch path. Okay, so BGP favors routes in INET.3. They also have a better preference to the INET.0 routes. Okay, so what we want to do, just a bit of recap here of how all this is working. So what I'd like to do is get in and we'll actually do the lab on this. This is the summary on route resolution here. So when our LSP is up, our LSP will be used. If our LSP is down, then our IGPs can be used. Our IGP next hops can be used. So MPLS is using 3 tables. We've got INET.0. So we can use INET.0. It's not the default. INET.3 is what we're going to use by default, and the MPLS will be used by MPLS.0 by transit routers for the label lookups and swap operations. And we'll look at traffic forwarding. So the ingress router will perform forwarding based on the destination IP address. It will resolve to the INET.3 for MPLS or INET.0, but usually INET.3, which is the default. After the next hop is determined to be the LSP, the MPLS header is added. Packet is forwarded with the corresponding label. So there we are. It's an example of looking at the INET.3 table, and you can see that the label is there. Transit routers use the MPLS.0 table for the lookups and swaps, and the egress router will do a pop operation and forward the label on. Or sorry, the penultimate router will do a pop operation. The egress router gets the packet without a label and does a lookup based on the IP address. So MPLS label mapping is done by the MPLS.0 table. So we have the incoming label, the next hop, the exit interface, the egress interface, and the swap label. And the penultimate popping is done by the second last router, and it is see that we've got a label pop operation set up there. So we've got an incoming label, and we've simply got a pop operation for the outgoing. We have this implicit null, which is the default operation for Junos operating systems, which means that it will, that value, which is a value of 3, a label value of 3, tells the router that receives that label that it should pop that label, not swap it. There's an explicit null which can be configured on the egress router, signals the penultimate router before the packet with a MPLS header. That's not the usual operation. The usual operation is the implicit null. Alrighty, so what I want to do now is let's go and take a look at these labs and get into doing the labs themselves. So I'll just jump out of that screen there. Okay, so what I want to do here is just get up on the screen. I'm just going to organize this. I don't need that one anymore. Let's get rid of it. Okay, don't need that, don't need that. Okay, so we've got our endpoints. We've got MX1 and MX2 down here. I'm just trying to organize this so we can kind of switch between them fairly easily. Alright, so to begin with, the starting point, is, let me just restart this. So for our starting point, the very first thing we do is configure the interfaces. Now, I've actually done that because that's something that you already know how to do. So all I've done so far, just to get started, is I've gone ahead and put the IP addresses on the interfaces, and that's basically it. I think it might be useful while we're doing this just to kind of refresh you as to what the topology looks like. So let's just get that. Let's get a look at that, and we'll get that up on our screens. Let's go back here. Up to there. We want to go and get that topology up on the screen there. And that's our lab diagram. So there it is there. This is our, here's our starting lab diagram. So essentially what we are doing to begin with is we're setting up these two interfaces here, which on our routers are actually GE000 and GE001. Why does the lab diagram say that? Well, this lab diagram is published by Juniper, and when Juniper run the lab, they use routers that have got different interface names to our routers. Okay, so unfortunately, it's very difficult to edit a writing in a PDF that is at 45 degrees. Okay, so we couldn't really get in and change it to make it into a 0 nicely. Not nicely, at least. Important thing to remember with our labs is that in the addresses and different values that are presented there, we've got X's and Y's. The X's are always 1s, and the Y's relate to the values that are on our lab diagrams here. So you've got to refer back to the lab diagram to see what the value of Y should be, and that's going to depend on whether you are working in MX1 or whether you're working in MX2 as to what the value of Y is going to be. Okay, so we'll come back and refer to that as we need to. Don't need that anymore. Okay, so what we've got here is just put the interfaces on, the interface addresses on. So 172.222.10.1. The other side of that link is 172.222.10.2. So I should have connectivity to that, and likewise I should have connectivity to 172.222.11.2 as well. So let's just check that, make sure that we do. I should be able to ping that. should be able to. If I can't, we have a problem. If I can't, we've got to sort that problem out first before anything else happens. Looks like I'm not pinging it, so make sure 172.222.10.2, and yeah, I should have that. I should have 211.2 as well. 211 should be able to ping that, which I cannot. Okay, I'm just going to do a quick check of my hosting environment here. Let's do that off the screen so we don't bother with what I'm doing there. I'm just going to check that all the virtual machines are up and running. And that something hasn't happened in the last few minutes. Let's have a look. That, and that. Yes, they're all up and running, which is good. Let's just yes. Okay. Let's jump back over into sometimes the links between the virtual machines drop out, and you just need to re-establish them. So I'm just doing that now, and let's come back and see if that doesn't work. Where that. That's looking better. So there we are. So now we can ping the other side of our link. Should be able to ping 10.2 as well. There it goes. So we can ping that. So that's a kind of a first test that you want to do, just to make sure you do have that connectivity. So what are we doing there? We're basically testing, go back, look at our diagram, we're testing that we've got connectivity from MX1 across to P1. So our first little check, and from MX1 down to P4. And of course we should be able to do the same test over on MX2. So let's go and take a look at MX2. We'll do a show interface. Oh, I need to restart that, don't I? So restart that session. Maybe it's just dropped out, is it? What's it done? I've just dropped that session. Have to reset it. Just wait for it to time out there. Okay. Alright, there we are. So let's do a show interface terse. We'll check our interfaces here. So in this case we've got 212 and 213. Remember the X is always a 1, so if we go back and take a look at our lab instructions, we find, well, even the lab diagram, the X is always a 1 and the Y is the value after the X. So we've got 212 and 213 are the values that we're configuring here. So let's just do a ping. I should be able to ping 172.22.2, oops, 212.2. There it goes. And I should be able to go 213.2. Now, if you can't do that, let me know, because I'll have to go and re-establish the linkages between the virtual machines. Just like mine dropped out, for some reason they occasionally do drop out. So I have to re-establish those. Okay, so that's what we want to make sure that we've got that happening, which we do, so that's good. Alrighty, so let's move our lab diagram out of the way for now. So the first job is to set up our IGP, which is OSPF. That's our first task.
I have a question.
You have a question? Yeah. Yeah. What was the?
The label edge rota, it corresponds to a BGP rota. Yeah?
The
label edge rota corresponds to a BGP rota.
Yes, the label edge routers are configured with BGP.
Yeah. So he's receiving so many traffic, different kind of traffic. How the router is gonna know when he's gonna to forward the packet to the label switch path, or he's gonna to treat the packet as a normal IP packet?
Okay, how does it know whether the next hop should be a label switch path?
Or it's going to be a normal, or
it's going to resolve that in the INET.3 routing table. So the information in that routing table will tell it whether the next hop is a label switch path. Label switch path will be in that table. So it will find the label switch path in that table, the INET.3 table. That's how it resolves it. Okay, so here we are on MX1. Our next job is to set up our IGP, and we're going to use OSPF. So in the configuration mode, edit, protocols, OSPF. Here we are. So what we need to do here is we need to put our interfaces and tell our protocol what area our interfaces are going to be in. So the command is set area 0. We're using area 0 because it's the only area we've got. And we're going to set up interface GE 000 dot, and now we need to put the unit number there, the unit number. So if we go back and take a look at our interfaces, right up here, there's our unit number 210 on 000 and 211 on 001. So that's what we're going to reference down here, 000, 210, and we'll just go back and change this to 1 and make that to 11. And then there's our loopback interface that we're also going to include in our IGP. Why are we including our loopback interface in our IGP? Exactly, because when we set up our IBGP peering arrangements, we're going to set it up between the loopback interfaces in our autonomous system, and therefore we must have reachability to our loopback interfaces for IGP to be able to set up a peering between them. That reachability is provided by our OSPF IGP. So there we are, we've got that set up so far. We are going to commit and go back to operational mode, commit and quit And we should be able to see a neighbor setting up a neighbor relationship here. So here we have OSPF starting up. This is the usual procedure, usual process of OSPF getting started, goes through its various stages and arrives at full. So there we are. We now have our neighbors set up. Now, to get the protocol working across our entire autonomous system, I need to go and set up the other side of this, the other VMX. So we'll do that. And we're going to go to Edit, Protocols, OSPF. And we are going to set area 0. Interface, what interfaces are we going to put here? Well, we're going to put GE000, so we're going to put this interface right there. I might just pop that right there, make life easy for myself. There we are. I'm going to pop that in, and we're also going to put in this interface here, GE001, with the unit number of 213. One and 3, so there we are, and we're going to put or include our loopback interface. There it is there. So let's take a look at that. There we are. Oops, I didn't get my loopback interface in there, did I? That's better. It's always good to have a check of your configuration before you commit it. Make sure you got it right. There it is there. Hit and quit. Back to operational mode. Let's check our neighbors. Starting up. Still starting up. Should get there eventually. Taking a while. Okay, struggling to get going here. I imagine it will get going eventually. One is full, and we should get the other one up shortly. Exchanging. So it's exchanging link state databases and taking its time. We won't be able to see our routes until this process is done. So I just have to wait for it to get done. There we go. So now if we go and do a show route, oops, show route protocol. OSPF is what I want to say. So there's our OSPF routes coming through now, and we should have a route going right through to the other end, which we do. So we really should have a route going right through to the loopback interface of the other MX device. So I'm on MX2, and there's a route going right through to the loopback interface of MX1. So I should really now have connectivity to that other MX device. So let's test that we do. 1.1. That's the loopback interface of MX1 that I am pinging there. Let's see if we have connectivity.
You said that it's a mistake in the topology. This interface we are going to use to communicate with the...
What was the question again?
It's a mistake in the topology, you know?
Well, the numbering scheme on the diagram is different to what we actually have. We've got interfaces from 000 through to 009. There are physical interfaces. So the lab diagram, instead of starting with a 0, it's the interface names numbers start with a 1. So if you replace the first 1 with a 0, then we're good to go. Okay, so we've got connectivity. I would say it's not great though. We've got 88% packet loss, so we're gonna have to do something about that at some point, but I'm not going to kind of worry about it right now. The main point is the configuration for our IGP is sorted out. We're going to have to do a little bit of tweaking on these virtual machines to get them running a little faster here. Okay, so there we are. Alright, so that's our IGP set up. If we go back to our MX1 and we do a show route protocol OSPF. There we are, we've got our OSPF routes. And we should go right through to the loopback address of the other device, which is right there, which means I should have connectivity to it. .1.2. .1.2. Yes, we should have connectivity to it. It's not looking great though, I have to say. So why don't I have connectivity to it? 1.2, that's the right address. Well, yes, we kind of do. Kind of. It's not great though. Alright, so we need to sort out why we're getting that packet loss within our virtual machines. There's something to have a look at, which we'll sort out. Alright, so that's our IGP configuration done. So the next thing we want to do is we want to set up our BGP configuration, and our BGP configuration is going to be between the loopback interface of VMX1 and the loopback interface of VMX2. So we'll go ahead and set that up. So let's go into configuration mode. First thing we're going to do is we're going to set the autonomous system number for our router. That is in the set routing options hierarchy. I'm going to set the autonomous system number, which is 65512. 65512 is the number I want. All good. Now we're ready to set up our internal BGP peering arrangement. So we're going to go to Edit Protocols, BGP. And we're going to set up our BGP groups. So the first group we're going to do is our internal peer. So we're going to go set group, and we're going to call this group my INT group. My INT hyphen group. Like that. That's what we're going to call it. And this type of peering is internal. So this is going to be an internal peering. What does internal mean? It's peering within the same autonomous system. So we're peering between MX1 and MX2, which are part of the same autonomous system. So it's internal BGP peering that we're setting up. We're going to set up the local address on this, which is the loopback interface of BMX1. Which is 192.168.1.1. So I'm setting up MX1 right now. So I'm setting up the local address as MX1's loopback address, and then I'm going to set up the neighbor, which is the address, the loopback address of BMX2. .192.168.1.2. Okay, so that's the setup there. Let's have a look at it. There it is. So we have got under edit protocols BGP. We set up my internal group. Type is internal. Local address is the loopback interface of this router, 192.168.1.1. The neighbor is the loopback address of VMX2, 192.168.1.2. Okay, so we're going to commit that, go back to operational mode because I'm going to be checking that. Now for the actual BGP peering to work, I've got to go and set up the other end as well. So let's go and first of all set up the autonomous system. We'll do exactly the same as what we did on MX1. Set routing options. Autonomous system is 65512. Let's go and set up our BGP. Header protocols BGP. And we're going to set our group. We're going to call it my INT internal group. Oops. I would say that in a operational environment you would give this group a more descriptive name. And this is type internal. We're going to set up the local address. Which is the local loopback address 192.168.1.2. This is where you can just verify that by referring back to your lab diagram, that's the local address. And now we're going to set up our neighbor. Which is the address of loopback address of VMX1. Let's take a look at that. So there we are, we've got our group, type internal, local address, which is our loopback address, neighbor, the loopback address of VMX1. It's good. Commit and quit. So what we're going to do is we're going to check to see how this is going, how our BGP here is going. Check BGP summary. So we can see that we've got the configuration is in place, but the state has not been established yet. Okay, so we know it's working when we see established under the state. That tells us that the peering is up. So it goes through a number of stages. Now in the open sent stage, so BGP is going through its process of setting up the peering arrangement. The BGP is a relatively slow protocol. Takes quite a while for it to get set up. Okay, so that'll eventually get into the established states. Okay, so that takes care of our internal BGP peers. The next thing we're going to do is we're going to set up a routing instance. Now, let's just refer back to this lab diagram here so we can see what's going on next. Okay, we're going to set up these routing instances. We're going to set up a CE1-1 and a CE1-2. So the 1-1 is going to be associated with VMX1, the 1-2 associated with VMX2. So what is the purpose of this? Well, if you take a look at the names that we're using here, we've got a PE1 and we've got a CE1-1. The PE is an abbreviation for provider edge. So the PE1, which is really our MX1 main routing instance, is going to be acting as a provider edge router, and CE1 is going to be acting as a customer edge router. So we're going to be placing CE1-1 into a different autonomous system to our PE. So there's our autonomous system for our CE, which is going to be 65101. We've got our PE over here in 65512, and the other CE is in 65102. So we've got 101 for CE 1-1, 102 for CE 1-2. Okay, so once we've got that set up, we're then going to set up an external BGP peering arrangement between the CE and the PE. Okay, so we'll let it have an external BGP peers between those two. So that's our plan. That's where we're going with this. Okay, so we'll just take that off the screen for the moment. And we'll just jump back into VMX1. Here we are. Okay, I want to have our BGPs going, by the way. I might just jump back over here and do a show BGP summary. Well, it's coming up. It's progressing. We are exchanging some information, so it's happening. What we're looking for is the word established to appear here. That's when we know it's up and working. Okay, so moving right along, let's get busy and set up our CEs. So we're going to go into Edit, Routing Instance. And we're going to call this routing instance, I'm on VMX1, so this is going to be CE1-1. There it is there. And we're going to set the instance type, which is a virtual router. Oops, set instance type. Virtual router. Here we are. Let's put some interfaces into our instance. We're going to be using GE008. Oops, 899. Yes.
The instance name is CE1 and
1-1.
1J. Is that?
1.
Just one.
Yeah, just 1. Yeah, it's a 1.
CE1-1.
1-1. Yeah.
Thank you. Okay.
So GE, yeah, that's actually on the lab diagram. If you want to take a look at that. So there's our first interface that we're going to include in there. We're going to include a loopback, but we're going to include unit 1 of the loopback. So we've already got our loopback in our main routing instance, which is our loopback unit 0. I'm going to include LO0.1. So there's a loopback interface, but that is unit 1 of our loopback interface. So really it's another logical interface. Okay, it's a completely different logical interface to LO0.0. So there it goes, we've got that in there. Let's do a show, see what we've got. So we've got the interfaces are in there, but look at these error messages that have come up. We've got GE008.0 is not defined and LO0.1 is not defined. What does that mean, that it's not defined? Let's go and have a look. Oops. Let's do a show under edit interfaces, and we will see we've got GE000 set up, 001 is set up, as our management is set up, and that's all, folks. Nothing else. Nothing in there about 008 or LO0.1. Okay, that's why we have the error message there. So what we need to do is go over into this edit interfaces now, and we need to set up these interfaces. So let's get that done. I'm going to set up a number of interfaces under here in actual fact for this to work. So here we are, we're going to go set GE. I'm going to set up 00, we're going to set up 004. We're going to need that. Unit 0. And the INET address. And we're going to put 10.0. Now this is VMX1, so the address that goes on there, you need to refer to this diagram. So I'm setting up interface 004, GE004. So here I am over here, 004. I'm going to put 10.0.10.1 on that, because the X is a 1, the Y is the 0 after the X, and then the .1 is the end, is the address on 004. So that's what I need to put there. 10.0.10.1. 10.0.10.1. That's a /24. All good. I need to configure interface GE008 as well. Let me just go and get my just drop that out of that there. just going to refer to the lab instructions here for this bit. Alright, so we're going to set, we want to set GE008. We're going to make that 10.2/24. Why is it 10.2? Because, go back to our diagram, we've got GE008 and we've got the .2 on the 008 interface. And now I'm going to set my loopback address. So the loopback address for CE1-1 0 set interface. Oops, set that's right. 0 unit 1 family, and the address is 192.168.11.1. So that's the loopback address for my CE. Okay, it is in fact a /32. If you don't put anything, the /32 is there by default anyway, but I'll just put it there. Let's take a look at that. Make sure we've got that right. So there's 004, 10.0.10.1, 008, 10.0.10.2, /24, and loopbacks. There is unit 1, 192.168.11.1 down there. So that's good. That's what we want. So far, so good. And we're going to commit that. And quit. And we do a show interface. Terse, we should see that configured up. There it is, 004 with its address, 008. And my loopback down there. Okay, so now I've got to go and do the same on the other side. MS2. And I'm going to go into routing instances. This is going to be CE1-2. This one. All good. So we're going to put the interfaces in there. This is GE. We need to put 008 in there, and we also need to do interface hello 0.1. Need to set the instance type as well to virtual router. Let's take a look at that. Instance type virtual router, and there's our interfaces which need to be defined under the edit interfaces hierarchy. So let's go and do that. To set up 004 unit 0 family. Oops. The INET, and the address is, for this one, I'm going to refer to the lab diagram to get our addresses over here. So this is going to be 10.0.11.1 for 004, and it's going to be dot 1 for 004 and dot 2 for 008. This is how that's going to work.
Sorry,
It's better there. Yep, that's the diagram we want.
try to follow you, but in my code I don't have even connectivity between two routers.
Okay, we'll have to get your connectivity sorted out. So we'll do that shortly. Let me just finish configuring up this, okay, and then we'll take a look at getting your issue sorted out. Okay, so the addresses are 10.0.11. It's going to be .2 on the 008 side, and it's going to be .1 on the 004 side. So this is 004 I'm doing here, so that is .1/24, and let's do the other interface, which is interface 008, and we need .2 over there on 008. We also need to set up our loopback interface unit 1. Unit 1. And the INET. And the address we want to put on that, we go back and refer to our diagram. Just drag that across again over here. Is 192.168.11.2. That's where we're going with that. So we'll put that over here. And that's A/32. Let's take a look at that. There is 004, 008, looks right, and check the loopback, 192.168.11.2, right, and we'll commit and quit that. Oops, yeah. see those configured there. There we are. Looks good. There's 8. And there's our loopback. Oh, good. Okay. Alright, so that's our interface is done. Okay, so the next step is we're going to set up our external BGP peers. Now, let's go back over there here. I'm just going to set up, deal with your issue. Deal with your connectivity issue there. What pod are you on again? What pod number?
I was trying to configure the interfaces.
Sure. What is your pod number?
I was working in 30 and 31. I got one. I don't know.
What are your device names?
4230 and 4231. I got that one.
Okay. Can you just tell me your device names? It should have that information there as well.
This one, NX1.
Yeah. Okay.
I'm working that one.
Alright, so you're on, let me just get that for you. So you are on 30 and 31, right?
Somebody working, is it there? Alright, can you assign to me another one, please? 35?
Sure.
Thank you so much.
I'll just set up. Yeah. Why don't you just try and use those, and and then we'll go from there. Okay.
Alright.
So I'll give you those ones.
35,
Okay.
36.
Yeah. 35, 36. Yeah. So
That's my name.
we'll set those up. Okay. We'll set those up. Okay. No problem.
Okay. I can access one.
You can't access your pod.
If they want the number one.
Number 1. 4221. Actually restarted yours, so it's kind of so I can ping it. $43.21 doesn't look good, does it? It's got a problem. Okay. Yeah, I just actually restarted yours, Tom. It's so strange that you can't access it. I'll have to come back and check that. Okay, we'll check it in the lunch break. So what's going on there? Alrighty. Okay, so we've got our interfaces for our CE set up. The next step that we want to do is we want to go and set up our BGP, our external BGP peer for that. So let's do that. I'm going to start over on VMX1. We will. First of all, we're going to go ahead and we're going to set up the peer on the PE side, and then we'll set up the peer on the CE side. So we'll do both sides, and we have to do that on both MX1 and MX2. So we're going to set up an external peer. In the configuration mode, edit protocols BGP. Take a look at what we've got there already. So there's our internal.
Yes. Sorry, just a second. Just for you. I don't have connectivity.
Don't have connectivity
Between this router. So I configure this interface.
Oh yes, we'll have to sort that out for you. Okay, sort all that out for you. So you're on pod. What pod are you on? I'll put you down here.
Yeah, that one.
8 there. Okay, let me just double check that for you. Okay, you're on 8. Okay, let's try that again. That should have sorted that out. Okay, so we are setting up our external BGP peers here. The group is going to be called My EXT Group. We're going to put type external. Now, it's not absolutely necessary to put that because external is the default type. But it's useful to put it because if you don't put it, it doesn't appear in the configuration. And if you do put it, then it appears in the configuration. It just makes it so much easier for anyone looking at the configuration to see what's going on. So now we're going to put the peer autonomous system. So the peer autonomous system, this is the autonomous system that we are peering with, which is going to be the autonomous system of the CE device. So if we take a look at that over here, it's going to be 65101 on MX1. 65101. So there's our peer autonomous system. Now we're going to set up the neighbor. Okay, so with the external BGP peers, the neighbor address is the physical interface that connects us to our peer autonomous system. So in this case it is 10.0.10.2. Oh yes, I forgot to put the word neighbor in there. That's better. Alright, so let's take a look at that. So we've got, so now we've got, there's our internal which we've already created, now we've got our external in there. Okay, so far so good. Now we're going to set up the other side of that peer. We're going to go to edit, routing, instances, and we're going to go to CE 1-1. And we're going to set the autonomous system here because it is different to the other ones. So we're going to set routing options. Autonomous system is 6.5. .1.0.1. 6.5.1.0.1. That's what we're looking for. It's all good. Edit protocols. Oops. Protocols. BGP is where we're going now. And now let's set up the other side of our peer, our external peer. Set group. My external group. Type is external. We are going to also put in the peering autonomous system, which is 65512, and while we're there we'll just add the neighbor in as well, which is going to be 10.0.10.1. Okay, how do I know it's 10.0.10.1? Take a look at my lab diagram. I'm configuring the CE, and my peer address over here is on the PE, which is the 10.0.10.1 address. So that's my neighbor's address there. Okay. Let's take a look at that. There's our external BGP peering. So let's commit and quit back to operational mode. And we should be able to do a show BGP summary. And see what's happening here. So active, by the way, active doesn't mean it's working. Active means that it's looking for an active connection. It should come up into established, which it does. There it is. So that's established. Notice our internal is still struggling. We've had 3 flaps, so it's been up and down 3 times. So we have to deal with those issues as to why is that happening. I have to sort that out. Alrighty, so that's MX1 done, and we'll do exactly the same on MX2. So let's go into configuration mode. We are going to set up our route. Protocols BGP. We're going to set up our external BGP peer. Set group. It's going to be called my external group. Type is external. I'm just going to go right ahead here and set up the peering. Just add on to here. In this case, what is it going to be? Let's take a look at our diagram. Over here, it's going to be 65102, which is the autonomous system of this CE1-2, 65102. And the neighbor is going to be 10.0.11.2. Let's take a look at that. There we are. Looks good. Let's go and set up the other side now. Over here, so it's going to set our autonomous system number, which is in the routing options. autonomous system is 65102. Now let's go and set up our BGP here. Set group my external group. 5 is external. Pure autonomous system is going to be 65512, which is the autonomous system number of our PE device, and the neighbor is going to be 10.0.11.1. Okay, so that's our setups there. Let's do a hit and quit. So BGP summary, that should become established shortly. It's connecting. There we are. It's become established. So there we are. So we've got our external BGPs running. I still need to deal with this little issue of why is our internal BGP struggling? It's really a connectivity issue that we're having here between our two ends. So I need to really take a look at that, sort out what's happening with that. Try and make that work better. Alright, so that's there we are. We've got the BGP configuration done. What we want to do, the next thing we want to do, which we'll just do before we go to our lunch break, or the next step actually is to save that configuration. Save that as a baseline configuration. Now, if you take a look at our FTP server here, let's go back up here and back up again. If you look under the MPLS hierarchy, here we are. Under MPLS, there is a folder called Students Work. There it is. And under Students Work, we've got all these different pod numbers. I guess you're going to have to know what your pod number is to save your work, aren't you? So let me just, I'll just have to publish that. I think I have published it actually. Yeah, it is. So next to your name, there's a number. Okay, so that number is your pod number. Okay. So that's it there. So I think I've already given you that information. Okay. First John? You don't have one?
No, I don't have it yet.
Okay. Who are you going to work with? Okay. You have to choose a partner. So you get to configure a VMX each. Okay. The thing about this is though that you can see there's a very close relationship between the two ends to get the peering working. So you can't, be going off to do your own thing without your partner. You have to work together. Okay. So I would recommend that you work together. Yeah. Yeah.
I can't reach the FTP server. I can't connect to the FTP server 10.10.42.12.
You can't connect to it.
Can't.
Huh.
40, sorry.
40.12. Yeah, it's 40.12. Yeah.
Yeah.
Okay. So then so save your baseline configuration up into your pod. You may need that later. Okay, so the next thing that we're going to do, I might just do that before lunch. The next thing we want to do is Now that we've got this peering arrangement going on here, we're not advertising any routes across this peer at all. Okay, now you may recall the thing about BGP is that every route that BGP advertises originally started out as some other kind of route that was imported into BGP, or maybe I should say exported out of another protocol into BGP. It's a better way of saying it. So it was either exported out of a static route, some other kind of route, maybe it was exported out of OSPF, whatever protocols. It was exported out of some other protocol into BGP, and now BGP then advertises that route. So that's exactly what we're going to do. We're going to set up an export policy to export the loopback addresses of our CEs into BGP, so that we will then advertise the loopback addresses through BGP right through to the other VMX at the other end. Okay, so that's our goal. Our goal is for BGP to advertise these loopback addresses from the external BGP session into the PE, and then via the internal BGP session from this PE across to this PE, and then ultimately we should be advertising it again from the external session right across into the other CE. Okay, so that's our goal, and the first step in our goal is to take the loopback address of our CE and export that route into BGP. That's our first step in the process. So how do we do that? Let's take a look at that. So I'm going to start off here on VMX1. But you didn't know there was going to be so much BGP in MPLS. There's a lot of BGP in MPLS. Alrighty. So here we go. Let's go. We're going to set up a policy. I'm going to set that policy up on both of our VMXs. Configuration mode. Edit policy options is where we need to be, and we're going to create a policy statement. Set policy statement. We're going to call this policy statement CE export loopback. Which is a user-defined name. We could have really called it anything, but that kind of makes sense. First term is from protocol. So our goal is to identify our loopback address. So the protocol, the routing protocol that it's actually in right now is direct. So it is a direct route, is directly attached to this router. So this loopback interface is a direct route currently. So from protocol direct, we're also going to go from, and we're now going to set up a route filter, and we're going to specify the address of the loopback interface. So we are here on VMX1, we're looking for the loopback interface address of CE1. So let's take a look at that again. Here it is over here. 192.168.11.1. That's the one we're looking for.
Why do you want to export by BGP from protocol direct if they have a direct information? You got this information already.
Hey, what's that?
Why do you want to export from protocol direct when this autonomous system knows about this network?
Yes.
It's a directly connection.
Yes. The CE router knows about the loopback address, but the PE doesn't. And we want to advertise that loopback address across ultimately to the other PE. So what we're trying to do, or what we need to do here, is we need to advertise this address over into the PE, and then the PE will re-advertise it across over to the other PE using BGP, and then ultimately re-advertise it across into the CE. Okay, so yes, we need to we want to advertise that loopback.
But why this segment of the network 10.00 you wanted to store by BGP as well? Protocol direct is this segment here, yeah?
Protocol direct is referring to the loopback address. In that okay. It is a directly connected route.
Okay. I thought you were referring to the 10.0.
So now we have specified the route filter for that exact particular network that we're looking for. And the next step is, so there's our matching terms there, if you like. And the next step is to just accept that. So term 1, just get rid of all that. Then accept. There it is. Let's take a look at that. Okay, here is our policy. Policy statement, CE export loopback. Term 1, from protocol direct route filter 192.168.11.1/32 exact, then accept. So that's our policy. Now what we're going to do is we are going to apply that policy as an export policy to our BGP external group in CE1-1. So that's our next step. So let's go over to there and get that done. Protocols BGP. I'm going to go into group, my external group is where we are going, down to there, and we are going to set export right there. Let's do a show. So that's where we're at. We have got an export policy sitting there now in that particular group. That's our export policy right there. So what we're going to do now is going to export the output of this policy, which is going to be this route, into our external BGP peer. So we'll commit that. Okay. So now to make sure that we're this is actually working, what I want to do is we'll actually check what we are advertising through this BGP peering arrangement here. So we're going to do a show. We'll just do this check and then we'll go to lunch. Show route advertising protocol BGP, and we want to know what are we advertising to 10.0.10.1. And what we can see now is that BGP is now advertising this prefix, okay, because we've now exported that into BGP. Right, that's what we're trying to achieve here. All right, we need to do the same over on MX2, so we'll get that done, and we'll have a look at that after lunch. So let's take a lunch break and catch you back at 1 o'clock.